All right, folks, back in action here. This is the last page of our vocabulary for circles. All right, we've got congruent circles and concentric circles. We're going to compare these side by side. These often get mixed up for students, so let's get these straight right now. So congruent circles and concentric circles, both of them have the same language here of distinct circles. And all that that's telling us is that the circles have to be different, okay? They have to be different circles. See, someone can't just say, hey, I've got this same circle and it's congruent to itself. The congruent circles and concentric, by definition, have to be different. Now, congruent circles, they both have something that's the same, but it's different of what they have in common. So congruent circles have radii that are the same, and concentric circles have the same center. So what does that look like? How is that different? So congruent circles, since they have the radii of the same measure, then what I'm looking for is, for example, a circle and a circle. Just two separate circles. Try to make yours look as close to you as they can to the same measurement. I'm going to draw in two radii here. And if we want to properly communicate that these are in fact congruent circles, what we would do is we would label those two radii as congruent. So now we can see that those are in fact the same. Now, our concentric circles, those are, really just think ripples in a pond, all right? Where you've got a circle and then you've got another circle, and we can have lots of them. Mine are pretty messy here. But those would all be concentric circles because they would all have that same center. So think a bullseye. Now our last thing that we've got in our list of definitions, and then we're going to get into a couple examples, is circumference. Circumference is our distance around the circle. In other words, it's the length of the circle. So if I have a circle here, that's a really good circle for me. Woohoo, I'm feeling pretty happy about that one. Then when I'm talking about its circumference, I'm imagining I'm starting at a point and I'm going all the way around the circle. So what I want to know is, how long is this? How far did I travel all the way around the circle? Now I know you guys have done the circumference formula before, and our circumference formula can be written two different ways. So circumference can be written as 2 pi r, or we can write our circumference as pi times diameter. Both of those are actually going to be useful, and we want to get comfortable bouncing back and forth between the two. So let's jump into a couple examples. Now, when you were in your elementary days, you probably often replaced this pi with a decimal approximation. You maybe used your calculator, or you replaced it with 3.14. But unless it asks us to do that, we are not going to do that. So we're always going to be thinking exact values, exact values, exact values, exact values. We are not replacing pi. We're going to leave that symbol in our answer unless it asks us to do something otherwise. So for our first one here, it says we've got our circumference is 7 pi. We want to find the value of the radius. So what we're going to do is we're really just thinking, hey, formula circumference is 2 pi r. I'm using that one since I'm wanting the radius. I can substitute in 7 pi for the circumference. And then I'm just doing my algebra, dividing both sides by pi. And then my radius, this one's quick and easy, then my radius is going to be 7 over 2. In this case, it looks like it's meters. Okay, so then we're just done with that one. Now the next one, if I want the exact value of the circumference, first of all, 1/3 is not going to convert to 0.3. It's a repeating decimal. So what we're going to do is we're going to take this mixed number and convert that to an improper fraction. So we'll have our 8 times our 3 is our 24, plus our 1 is going to give us our 25. So we've got our 25 over 3 here. We're going to use that for our diameter instead of this mixed number. So since I'm given diameter, I'm going to work with that formula. Circumference is pi times my diameter. So my circumference is going to be my pi over 1. Always think of that as over 1 if the other one is as a fraction. 25 over 3. So when we write this answer, we're going to write it as 25 pi over 3. We are not going to convert this to a mixed number. We are not going to convert this to a decimal. If you do, I'm marking it wrong because those numbers are not as useful for us. Now, how are these basic formulas going to be useful for us? How can we actually apply these to some of the things that we already know? So let's say I'm asked to find the circumference of this circle, and what I'm given is this figure with this triangle here, and I've got this nice right angle. Well, what I notice on this triangle is that this is a 30, 60, 90 triangle. So a little bit of review of the last chapter. I'm given the long leg. So my radius of my circle is actually going to be my short. So I'm just going to take my 21, divide that by my radical 3. I'm pretty comfortable with this now because we've been doing this for a while. So I have this 21 radical 3 over 3, which means the radius of my circle is simply 7 radical 3. So my circumference, I'm given the radius, so I'm going to work with the 2 pi r. So I'm going to have 2 times the pi and my radius of 7 radical 3. So when I write that final answer, I'm going to write 14 radical 3 pi, and I'm going to put a u on there for units because I don't know what this is being measured in. Now, technically, we could reverse these two. We could write 14 pi radical 3. This is just typically how I write it, but I'll certainly take it the other way. All right, last one that I've got going on here is going to be find the circumference of this circle right here. I've got the circumference of this circle, and I'm specifically given the fact that this triangle is equilateral. Now, if the triangle is equilateral, I know that this is 60 degrees. Now, from the last chapter, what we did is we did a whole bunch of things where we found the height, and I don't want to lose that center there. We found this height. So if that's 24, then this piece right here is going to be 12, which means this entire height right here is going to be 12 radical 3. Now, what we learned last semester that you may or may not remember is that this center right here, this center of this equilateral triangle that also then happens to be the center of our circle, that this center is a centroid in this equilateral triangle. Now, it's not all shapes, but specifically in the equilateral triangle, our center is the centroid. And what we learned last semester is that we know that the centroid, the distance from the centroid to the vertex is twice the distance from the centroid to the side of the triangle. So if that's true, then what we can do is divide this up. We know that this is going to be 2/3 of that, and this is going to be 1/3. That means then that the top piece here is 8 radical 3, and this bottom piece is 4 radical 3, which means we can now see that the radius of our circle, okay, remember the radius has to go all the way to the circle, so the radius of our circle is going to be 8 radical 3 in this case. And yes, you do need to know how to do this. So the circumference is 2 pi r, and that means that we're going to have our 2 and our pi and our radius of 8 radical 3. So we can write our final answer for our circumference as 16 radical 3 times pi, or remember, you could reverse those, put a little u on there for units. All right, so that's a great review, reminding us that the centroid is going to be twice the distance from the centroid to the vertex as it is to the side, allows us to divide up that height of that triangle. All right, that's all that you've got, and we are going to build on this when we get to class.